go to image. If you want to know something about the image, sometimes it's complete, sometimes it's brief, but if you go to image, show info, you can find out something about it. And in this particular case, the date is interesting, the time would be interesting. We're not going to go to all these images, but this is universal time 4:01. The next image will say universal time 5:01, and so on. I'm just calling them 4, 5, 6 later. Okay, so we want to, we'll just set that aside for the moment, and let's bring out Jupe 6. Do the same thing so you can click on the moons. So once I've clicked on Jupe 6, it's active, and I can click auto. Maybe a couple of times again. Kind of set them side by side so you can examine them a bit. Now these are all taken from the same telescope, same camera, just an hour apart, so the plate scale is the same, the sizes of the images are the same, all of that. And I think these are also aligned, I know they are aligned, so that if you were to put them on top of each other, Jupiter would match every time, okay? Not the moons, but Jupiter. So, 1 hour after that one, right? You see any differences in this one compared to that one? We could call this moon 1, 2, 3, 4. 1, 2, 3, 4. So say moon 1. Can you tell anything different? A little hard to say, huh?
A little higher.
Maybe a little higher on this one?
Yeah.
Okay.
Like the level.
All right. How about this one?
Close to the.
Yeah, it's quite a bit. That's obvious, right? It's so close together. This one?
Farther from the Jupiter.
A little higher?
Yeah.
And maybe this one? Probably a little lower, huh? Okay.
Slightly lower, yeah.
So we can see a little bit of movement in those moons. Okay. Let me show you a nice way that we have of combining these two images so you can see the movement much more easily. And this is a technique that's used by professional astronomers to detect asteroids moving, comets moving, anything out there that's moving in position over time. Now, if it's just 1 hour, you may not see a comet moving, but you might see you would see an asteroid moving if it's moving fast enough. So, I'm going to highlight Jupe 5, and I'm going to go up to Process, and I'm going to go to Image Calculator, and click on that. So you'll have a little window that looks something like this. Okay, are we all together? So I went to Process, Image Calculator, and that's where I am. Okay, up here in Image 1, we're going to put Jupe 5 there. We could do add, but and it takes time to see see what that does. We're going to say subtractor. And we're going to put this at Jupe 6. And yes, click or click to create a new window. And then click OK. Now, don't worry too much about this. When software programs, when the images become saturated or the pixels are as strong as pardon me, I need to diverge. Masaki, is this supposed to be recording what I'm doing?
Yeah.
I don't see it on your screen.
Oh, it's not? Okay.
I see Google.
No, it's in photo mode, it's not in video mode. Yeah, can you see? Yeah, it's in photo mode. Just play to the video.
Oh, no, it's no video.
Sorry for the delay here, but
Oh, what happened?
Do we need to reconnect or?
Wonder, let's see. No screen flow. Okay.
Okay, there you
Something
go.
happened.
Is it recording?
It's recording, yeah.
Okay.
I don't know what happened to the
All right,
screen.
okay. So as I was saying, this kind of mess in here is because when these pixels saturate and then we're combining, we're saturating, we're subtracting and so on, they really distort what's really there. So it's kind of a mix of the data, but that's not our concern in this particular activity. We're interested in the moons. And if these images had been misaligned, then we would see two Jupiters kind of ajar and so forth. But the images in white are from Jup 5, and the images, the black images, are from Jup 6. Okay, and in effect, it's kind of like algebra where you put positive, negative numbers, and the positives are white and the negatives are black, and so that this indicates the thing that we subtracted, the black ones. So clearly, then you can see that between 5 and 6, this has moved down, this has moved down, this has moved out, and this has moved down, right? Real clear.
What it did is Jupiter.
And Jupiter has stayed the same. Huh?
Moves a little bit, no? There is some overlap, I see.
Well, that's what I was saying. They're pretty closely aligned,
Yeah.
but not perfect. Not a perfect alignment. We used to have our high school students take these 6 images. They were definitely way out of line. We would have them highlight a moon, probably one of the little, no, we couldn't highlight the moon. We'd have to locate the center of Jupiter and then find out how much it was shifted from the second image, have them shift the image, which you can do, shift so many pixels up to the left or to the right and up, and then finally match them up, and that was quite a pain. Not that you shouldn't learn how to do that, but when you have limited teaching time, you don't want to have them do all this detail sometimes. Okay, the movement there we can see. Now I'm interested in combining all these. So I'm going to take this image. I'm going to go up here to Process, Image Calculator once again. You might note that this new image says result of Jup 5. It's just the way this software indicates it. So we're going to start up here in the image calculator. Image 1 is result of Jup 5. Put it at the top.
Right.
And now, so that we can have alternating black and white colors in the moon, what do you suppose we're going to do here? Add. And that must be, where, so I can't find add. No. Where's add? At the
It's
bottom.
above the, yeah,
There it
above
is,
the-
okay.
yeah.
All right. And then Jup 7.
Yeah.
We've already done Jup 6, right? Jup 7. At this point, you don't necessarily need to create a new window, but you can go ahead and do that, because we've already got a new window here. Okay, and we get this. So now, this is a little bit difficult to view, so what are you going to do here to see the moons?
Press.
What are we going to click? Auto, yeah, click auto. There we go. Once again, you can see the movement. It's going in the same direction. Same direction that it was earlier. So what I'm showing you here, first of all, is a technique for detecting motion. You could do this with images with asteroids. We're going to do that tomorrow with an asteroid, so we can see an asteroid. You can do it with this. You can do it with any other movement that you suspect, even a planet going through a field. So that technique of adding and subtracting, or just subtracting. Typically it's 2 images and you subtract one from the other and then you look at the difference. And if it's all the same, then there's nothing there to look at. Okay, now we could keep doing this 3 more steps to add in I guess subtract in 8, add 9, subtract 10. I'm not going to have you do that. I think that in this setting here with the workshop, you get the idea. We don't need to go through and do that. So what I'd like you to, but we have done that or provided you with that image by going here to File, Open, and click on Composite. And then once again, you're going to need to click Auto. Maybe a couple of times, let's see. So we're seeing this kind of complexifies it a bit, makes it more complex because it's kind of a little hard to distinguish between these two. So you've got to kind of keep track of what's going on. 1, 2, 3, 4, 5, 6, right? And then 1, 2. These are 1, 2, 3, 4, 5. What's going on there? That's a little interesting, right? Whereas this one's going out, 1, 2, 3, 4, 5, 6. This was coming in, 1, 2, 3, 4, 5, 6. Those are all nicely separated. But that particular moon at the bottom, we call moon 1, is doing something interesting. That it's getting closer and closer together, and the last two are all practically on top of each other. Okay. How many of you seen Jupiter through a decent telescope? I don't mean a gigantic telescope, but a decent telescope. So when you see the moons of Jupiter, you see them in lines, right? And if the planet's here, you might see one up here, 2, couple down here, or 3 up here and 1, or sometimes all 4 up here and then one's down here, or that. Have you seen that? Those of you, okay, so you know what I'm talking about. And this is certainly what Galileo observed 400 years ago. I mean, that's what he said. Wait a minute, what's going on there? That's confusing to some because it's, wait a minute, this textbook picture, we've got Jupiter here and these moons going around this way, right? How come we're not seeing circular orbits? And of course, the answer there, and this is where I'm going to make some assumptions with you, but you wouldn't necessarily want to do this with your students. Ask them, how come? How are we looking at Jupiter? How come we're seeing these lines and these straight lines? And wait a minute, how come we're not seeing circles? Those are really good probing questions to ask the kids, and that's where you could get them to create a model, and then maybe they have them look from the top or the side, or that kind of thing, to say, wait a minute, what is going on there? To get the idea of a perspective. Here's where I want to show you one. I don't know if I can pick it all out. Got too many things on my screen. I should have left something on. I wanted to show you a little model that some of us built up. Alan was a part of a workshop we did on modeling. It's a mini workshop, not the whole course, but I'm sure some of you have heard of that. Modeling in physics and an approach to teaching using modeling. So let me see if I could just move some of these things off. I wanted to show you the file that I have, and if you want to go to this file yourself, go right ahead. It's available to you. I've got a file in here in the moons of Jupiter. It's in the big file under high school files, moons of Jupiter. It's called Turntable Model. And we created this with a turntable, ping pong ball, one ping pong ball, and the ability to have it rotate. And then I took a digital camera, this is several years ago, from this side, from the edge, and you'll see what it looks like here. Open with, this is a QuickTime video, so it seems it works best with QuickTime, but we'll bring it up. I hope we'll bring it up. Oh no, that's right. Okay. This also plays with other players, but I find with QuickTime I can do some things with it that I can't with other. So here's a setup. You can see we're a side view. It'd be even more effective if it were even down lower, so you couldn't even see the turntable. And then I put a grid behind it to actually do some measurements. So I'm going to just run this. So we're getting some idea of why we might see these moons moving in straight lines. Because all they're doing is moving back and forth right along this line, right? Now, the fact is we can see the turntable, we can see it's turning and so forth, so you can connect the rotation with the straight line, so it doesn't do the whole job, but it helps a little bit. And then if you can actually, with this one, I can take, I can move it. This is, I think it's 1/15 of a second per image, moving across there, and all of a sudden, it's a very sharp image. You know, that's in focus as opposed to, and that's pretty much in focus. But then it starts to get blurry again, more blurry. The blurriest right in the middle, right? Now we know this moon is moving in basically a constant velocity, pretty close to constant speed. It's a decent turntable. But on the other hand, on the edges here, we're seeing these images that are very sharply focused, as though it's not moving. Well, it's actually moving this way, you know, over. And so that's what's happening at the bottom of that, the image we just looked at a few minutes ago. Those two moons practically on top of each other. I mean, if I take this back and forth, if I were to, between this point, if I were taking a piece of data, and that point, distance from the center, and that point, there's very little change in the distance from our perspective, right? Even though they're going back or forward, depending on our view here. So that must be what's happening with that particular moon in that image, and in fact it is. So, questions about anything I said here? Yeah.
So you're saying that how that moon had shifted is because it's come forward? Or from the composite image, it looked like that moon one had shifted a little bit?
Let me come back to that image. The question is about that image that we combine all together, composite?
And relating it to what
Yeah,
you showed.
let's come back to that. Okay, composite. No? Oh, there it is. Okay, that one. I think I'm going to minimize these others, so I just keep that one. Well, first of all, the perspective is that we're seeing these move in this dimension, right? But in fact, they're going around this way. Okay? So down in here, we're seeing these kind of come around the corner. And instead of appearing to go down, it's more like they're coming out toward us or into the board.
Also, that's why there's a different distance.
Sometimes they call that a turnaround point, or I think maximum elongation is an official term in astronomy, where it's you know, that moon came from, well, it started here, but it's somewhere behind Jupiter. It's a little bit hard to get the perspective, and then as it's moving down from our perspective, it's actually kind of coming around the corner and coming around this way. Does that help? Okay, yeah. So we're going to do something with that in just a minute related to the mass of Jupiter, and we won't get through the whole thing, but there's one final tool that I wanted to show you here, which is it's fun, and it even displays this even more.
Is there, well, while we're still talking about this, we saw that happen on the moons up here too. Is there any way to tell from the image which way the rotation is going? Because when I looked at, like, when we superimposed 5 and 6, one of the moons moved the opposite way,
Mm-hmm.
right? They all shifted down except one shifted up. It's like, oh,
You
yeah,
mean
turn the
opposite,
corner.
meaning toward the planet or away from? Is that what you meant by
Yeah,
opposite?
like all the moons had shifted downward,
Yeah.
except one shifted
Uh-huh.
upward. I thought, oh, look at that, it turned the corner. How interesting. But
Yeah, it
and
is.
when I looked at that, I thought, oh, it came from the back and went forward, and that was my perspective. But what you just told us now is that they're actually, the rotation is the other way, right?
Whatever rotation I showed you, I don't know that.
Ah.
I can't really tell which way the rotation is from these images.
Okay.
I'd probably have to look it up on a planetarium
Yeah.
program and say, okay, so this is the perspective, and so they're rotating this, but as far as, I've never,
I think you're right.
I don't
They're
think
all
I've ever been
rotating the
able to
same-
tell whether this one's coming from having been behind Jupiter, coming out, or going in. I can't tell that from this image.
They're all going the same way, though.
Yes, they are all going the same way, yeah. But just like the QuickTime here. Let me do this. If we could not see the turntable,
Right.
you couldn't really tell in this corner
Right.
whether it's going back or forwards.
Yeah.
It's just, we have a perspective. I've thought about redoing this sometime and kind of blocking out the bottom of the turntable, so all of that, block all that out. It might be even more realistic in how we do it.
But then the size of the ball changes.
That's true, the size does change a little bit, yeah. And this is close enough that you do seem to get a little bit of depth, yeah. Yes?
Could you measure any kind of a blue shift or a red shift in something that small from the light?
I don't know. I mean, that's what they do with planets going around a star, right?
Right, I mean, to try to see if it's coming towards you or
Yeah.
you'll get a shift in the.
I don't know if the speed is enough to give you enough
That's
much
what
of a
I'm
shift. I
wondering.
wouldn't think so.
I don't think it's enough. I'm just curious,
I've never looked at those numbers, like the speed of a planet going around a star versus a
right?
moon going around a planet.
Yeah.
Do you all know what we're talking about? I mean, have some idea? The discovery of exoplanets, extrasolar planets, at least one method is to measure the Doppler shift from the light of either whether it's going around this way or that way, something like that.
The light is from the star, though.
Huh?
The light
Oh,
is
you're
from
right.
the
The light's
star.
from the star.
This
That's
is
right.
This is
It's not from the
reflected
planet.
light here.
This
Yeah.
is reflected light.
It's
Okay.
reflected light, but either way, the light coming to you is either gonna be compressed or it's gonna be elongated.
I don't know.
I just don't know if it's fast enough to make a difference that's visibly noticeable.
I think reflected light would act the same no matter what it reflects.
Wouldn't you
I'm not
get
sure.
Wouldn't you get
You'd still get a Doppler effect.
You still get a Doppler effect, but maybe I don't think it's enough.
Wouldn't it be
I just think it's not measurable.
Ooh, this sounds like a
That's just throw it out.
juicy little topic. Yeah.
So, one thing that'll really help you if you're looking for Doppler shift is spectral lines. And so I think the question is whether the reflected light off of the moon will still show you any spectral lines. I think the answer is probably yes. But we should look up what we should calculate what the velocity is and then that will tell us. But we get pretty high precision for measuring exoplanet velocities.
Right.
This sounds like a little good question for a little research project by somebody, maybe even a student, huh?
There you go.
Interesting question. Let's see. I think I answered that. The earlier question was about whether you could tell which direction they're going, and at least from these images, you cannot. I wanted to show you one other technique. I'm going to close this one. I hope that all of you still have the. Well, I want you to have on your screen 5, 6, 7, 8, 9, and 10, but not the composite. Okay, so if you need to close stuff, do that. Result of Jupe, take off Jupe 5, a result of Jupe 5. So I need to open up What do I need to put 6, 7, 8, 9? I need 5 and 10. Okay. Open 5 and 10. Okay, so let me clarify that again. I want you to have open 5, 6, 7, 8, 9, and 10, close composite,
Yeah.
close result of Jupe 5. I think those, maybe there was another result of Jupe 5, I can't remember. Just 5, 6, 7, 8, 9, and 10. I've got 5 here, 10, 6, 8, 1, 7. 7 up there. And I want 9. Okay. Okay, you got them? And let's see, we're gonna have to, no, I think we can do this together. I hope so. So we're gonna go, this is a way of seeing this movement in motion. So we're gonna go up here to Image, Stacks, okay? And Start Animation, no, pardon me, Images to Stack, okay? Image, Stacks, Images to Stack. Click. Okay, this is what's called a stack. Some of you may, I mean, it's basically putting all the images together in one single file stacked in the way that they're describing this. And you can actually, what we need to do now is get the moon so we can see them. So, and I hope that does it for all of them. Yeah, it does, okay. If you just click the stack and click auto. Now, are you with me and you're still doing that?
Mine says all images have to be the same type.
Yes,
For some reason or
same
another,
type, same size.
I must have something else open that's not allowing me to do it.
The composite
It's
would be
gone.
different. Yeah, you just have to have those 6 images.
Okay, so if I minimize the composite drawer, I have to close the composite.
I think you have to close them,
Okay.
yeah,
That might be what's wrong.
yeah. Because I think Salsa J is still gonna recognize it. If there's a problem, I would say close them all, then reopen the 6.
And then what did I do to get there again? I'm sorry. Analyze,
No, image,
image,
stacks, images to stack.
Yep, good, thank you.
Did it do it?
Yep, it worked.
Okay, so 2 things we're going to do here. One, there's this bar on the bottom. Just click on that bar, and you can click between one image and the next. Go back to the beginning. So you can kind of see the moon's moving, right? All right? But now, and I think if I can, we're going to brighten this up even a little more. So I clicked auto another time just to get a little brighter. I think I clicked auto a total of 3 times now. So go to image once again, stacks once again, and down to where it says start animation. This is also in other software programs called blinking. Although you usually only blink between it. Click it.
Yes.
Wow.
And you see them in motion. There we go.
Wow.
At least I get one wow. Okay. So this is kind of fun to see this. This is a little speedy to really closely follow what they're doing. Sometimes it looks like those 2 up above, you know, you're not quite sure are they passing each other and then going the other way? So you can slow this down. Go up to image again, stacks again, and the very bottom, animation options. Okay, I'll hold that for a minute. Click on that. And then the speed, I usually reduce it down to 3 or 4. Let me just go to 3. And then okay. Other things you can do with that, but I think this helps really see what's happening. And even then, the two moons at the top, because they're going in two apparent opposite directions, a little confusing, but. So that's kind of what the ping pong ball model was showing, although I was showing just one moon and, you know, and I was doing the full orbit. Now you can see, if you can imagine, you know, the moons go around all the way. So they're going to take a lot more longer than 6 hours. But we're seeing partial orbits. Okay. So any questions about that? Yeah.
Can we save this into a video? Save
You can put it into a video? Yes, I'm sure you can. You've done
this. On
that?
the old version.
Can you do it with Salsa J?
Yeah. Now my computer cannot install the new version. But in the older version, no save.
But this is a newer version. Is there a video possible on this one?
Her computer will not run the new version.
I heard that.
Okay. And I have not experimented to see if there's something in the new version. If you go to save file or save as, if you save it as a GIF,
So if I go here to save as, you're suggesting this, right? Let's see if I can do this. Save as AVI.
Yeah, that should work.
Okay. I'll try it.
Okay, thank you.
See what happens. Stack AVI. Well, I guess that's what I'll just call it. I'm saving it in that folder. Okay, so now I close this, and if I go to that folder, should this do it? Maybe? Okay. File is not supported format. So I don't, there may be another way.
Oh.
But that,
If you did GIF, it makes an animated GIF.
oh, well, I can't go back now, but
Because I just did it and it seems to be an animated GIF.
well, what the, we only have 5 minutes here, so that, I'll give it a try. Well, because basically I've gotten to where I think I should just get for this afternoon for my part. So if I bring the 6 down, the 6 files, go to image stacks, images to stack, then I go animation, is that right? I guess that's what I do. Start animation,
No,
but
it's
I
a
need, here we go. And then I save as
Save as GIF.
GIF?
Yeah.
GIF,
yes. GIF.
Oh, GIF.
A gift?
GIF. Yeah,
GIF. GIF.
There's two schools
Okay.
of thought.
So I've got stack.gif,
Jiffy.
GIF and GIF. Okay. So,
And then, you have to have something that can play the animation.
that's, okay, all right.
But if you double click it, I mean, I even got the AVI to run as a
was gonna say, here's
movie
the
because I
AVI,
had
right?
an automatic conversion.
You got it?
That's an AVI.
Yeah.
It runs on.
AVI?
Yep.
So you need an AVI player, right?
Yeah.
Yeah,
Yeah,
right.
it just runs on,
QuickTime plays AVI.
yeah,
QuickTime.
QuickTime or,
Okay,
I don't even know which one this
All right.
is.
Yeah, the Mac converted the AVI to QuickTime.
well, we're also gonna see in Solarium how you can see the motion of the moons. I'll probably compare it with this, of how you can move them, have the moons moving and see them in 2 dimensions, or maybe even 3 dimensions, I can't remember. So to end my piece here for now, tomorrow when we pick this up, we're going to be using the 6 images, actually take some measurements using the, the line tool, the slice tool, measuring distances from the Jupiter out to the moons. We're going to have some partial data there, but it turns out that we can actually use that partial data to figure out what the period of this moon is going around the Earth, going around Jupiter. Even though it's only a partial piece of data, we're going to get a pretty good approximation of the period of that particular moon. Happens to be the moon Io. Of the 4 Galilean moons, this happens to be Io. And we're going to use that information plus another piece to actually then calculate the mass of Jupiter. There's a physics. I see your hand, Bonnie. Just a second, please. There's based on Newton's laws and gravitation and so forth, Kepler. If you know the radius, the orbital radius of a moon going around a planet, and the period of time that it takes on orbit, you can calculate the mass. In this case, we're going to know that for Io, or we're going to determine it for Io. We can calculate the mass of Jupiter. That's what we'll do tomorrow. So.